This is the companion video to our paper AI-based framework for robust model-based connector mating in robotic wire harness installation that showcases footage of our experiments. We consider the problem of inserting connectors into sockets in the context of wire harness installation, here for the center console of an automobile. We propose a connector mating approach based on tactile search, on which the robot repeatedly probes the surface until the connector drops into the socket. By first-order optimization over a learned surrogate model of the forward dynamics of the search, we optimize the search pattern to best fit the stochastic properties of the environment, such as the inaccuracies of feeder systems or the flexing of workpieces. By repeatedly executing a pre-parameterized tactile search program in the environment at hand, we collect a training dataset for the surrogate model of the search. In our experiment setup, we imitate real-world process noise by randomly perturbing the position of the center console using a linear axis. We collect end effector position and force data, as well as an image of the region around the end effector taken by a flange-mounted 2D camera. We collect 4,000 training runs for each of 5 connectors and sockets inside the center console. Using this data, we train a partly neural differentiable forward model of the dynamics of the search process that predicts the end effector poses, forces, and search success given an image of the current environment. The trained model forms the basis for a model-based optimizer that optimizes the search pattern given an image of the current environment. We compare cycle times and success rates before and after optimization. Before optimization, successful search often requires a large number of probes to compensate for process noise. Optimization reduces the average number of probes required by up to 73% and increases success rates by up to 47% depending on the connector. Robustness and cycle time were improved across all 5 connector geometries and socket locations.